Hello and welcome, boys and girls, and grown ups as well. Where are you right now? You say, I am sitting at home. Well, but where is your home? What is your location? You then say, I am in London or in New York or on an island, the island of Puerto Rico, for example, whatever. Everybody knows these places. Everybody can find them on a map easily. Now, imagine you are on a super holiday and you are cruising aboard a luxury ocean liner, and I ask you the same question. Where are you right now? Um, it's not that easy to answer my question, right? What would you do? Most probably, you would open the ship information system on a mobile device and check the actual position of the ship. The system would show you something like this. Well, what does it mean? Welcome to the Greenwich Royal Observatory in London. Yes, they pronounce it Greenwich, not Greenwich or Greenwich, but Greenwich. I am sitting in the so-called octagon. No, not in Pentagon. This room is called octagon because it has 8 walls. This room was designed by Sir Christopher Wren, the architect of the world-famous St. Paul's Cathedral located in the city of London where I live. Octagon was built mainly to make impression on important visitors. Now, I am making this video here to make an impression on you. The Greenwich Royal Observatory played a vital role not just in the history of observing stars, but also in the history of sea travel and navigation. Where are you right now? In a city? You give me an address. In the nature? You can measure distance you traveled and identify the cardinal points. But what to do when sailing in the middle of the ocean? How to measure distance and how to know your position? By the year 1700, skilled seamen were able to find their position north or south, their latitude. But the big problem was to calculate their east-west position, known as longitude. At the beginning of the 18th century, international trade had been growing rapidly, and losing lives and valuable cargoes in shipwrecks was a big problem. Solving the longitude problem became very urgent for all seagoing nations. Two methods proved practical. The so-called lunar distance method, which involved mapping of the night sky and predicting the motion of the moon. The other method was the development of a portable clock that could keep accurate time aboard ships. To work at sea, a longitude timekeeper needed to be both accurate and portable. Well, the watches were not accurate at all, and the clocks were not portable. In July 1714, the British government offered a huge reward to anyone who invents a practicable and useful method for determining longitude at sea. Anyone who could find a solution to this absolutely crucial problem would be rewarded. However, the solution must be accurate with a maximum variance of half a degree. Then The person or group would receive an amount of £20,000. This money in 1714 equals £3.2 million in our days in 2020. Meow. This longitude challenge or contest attracted a large number of scientists, craftsmen, as well as lunatics. 12 years later, in 1726, news of the longitude challenge had reached John Harrison. He was a carpenter and also a self-taught clockmaker living in Lincolnshire in England. What? It took 12 years? Nowadays, the news would reach him in 12 seconds via online news or social media. Yes, that's right, but this all happened almost 300 years back in time. When the news had reached him, John Harrison was already making highly accurate clocks and had solved major problems with temperature change or friction. On one hand, he was not a scientist, but on the other hand, he definitely was not a lunatic. What happened next? John Harrison spent 45 years of his life developing sea clocks that would keep accurate time regardless of a ship's motion and temperature changes and so on. He developed several models, not just one. Each model represented years and years of labor. In 1736, John Harrison introduced his first sea clock called H1. It was tested on a sea voyage from England to Portugal and back. Harrison was terribly seasick, but the clock worked well. In those times, it was the most accurate sea clock. However, it was not accurate enough. John Harrison did not get the full reward of £20,000, just £250 to improve his sea clock. He moved from Lincolnshire to London and got back to work, and he worked very hard. A few years later, he presented H2, an improved version of the sea clock. It was good, but not good enough. John Harrison spent 17 years working on his third sea clock. It was very good, but not good enough. John Harrison worked hard more than 4 decades, and at the end of the long story of clock models and testing, improving clocks and further testing, at the end of the long story, he invented a sea watch. Harrison's chronometer H5, 5.2 inches or 13 centimeters in diameter. So small! It looks like a modern pocket watch, right? This timekeeper revolutionized the sea travel. The year was 1772. His Majesty King George III himself tested the watch in his palace, and after a long 10 weeks of daily observation, he found it to be accurate to within 1/3 of 1 second per day, which was absolutely amazing and unbelievable in those days. Meow. What about the money? The reward promised back in 1714. Over the years, John Harrison received a total amount of £23,065. The last amount of £8,750 was paid to him in 1773, 47 years after he started working on his H1 model. He celebrated his 80th birthday the same year. They called him John Longitude Harrison. He showed and proved that marine timekeepers could work. Watchmakers developed his ideas and started producing affordable marine timekeepers for all ships. By the end of 18th century, determining longitude at sea was a practical task that could be carried out by any well-trained navigator. Astronomical data provided by Royal astronomers working here at the Royal Observatory were available together with reliable and accurate marine timekeepers. This made the so-called lunar distance method I mentioned earlier a viable technique for accurate navigation, position of the moon in time, and accurate measurements. Meow. There is a direct relationship between time and longitude. At any moment in time, local solar time at a given location varies by 1 hour for every 15 degrees change of longitude. 360 degrees is divided by 24 hours. In case the navigator knew the time at a fixed reference point when something particular happened at the ship's location, the difference between the reference time and the apparent local time gave the ship's position relative to the fixed location. Sounds too complicated? No problem. Very simply said, it is about what we call time zones. When something is happening now, then that now for me is, for example, 12 o'clock noon here in London. However, if you are sitting in New York, the now for you is not at noon, but at 7 a.m. in the morning. It is the same moment, but a different time in a different destination. Knowing the time difference helps you to determine your position. In 1884, the United States hosted the International Meridian Conference, attended by representatives from 25 countries. They agreed to adopt the longitude of the Royal Observatory in Greenwich, the so-called prime meridian, as the zero reference line. Due to the fact that those 25 countries represented the key powers of those days, since then the Greenwich meridian became the zero line. Where to find the Greenwich meridian here on the land of the Royal Observatory? Right there at that tree. Look, I am standing in the west now. I am standing in the west and east at the same time now. Every year, crowds and crowds of tourists come here to do this and to take pictures doing what I just did. Why? The feeling is very special. Meow. When you come to this place yourself, I'm sure you will do this as well. And of course, don't forget to visit the observatory and the garden. It's really worth it. I will be very happy to hear from you, boys and girls, and grown-ups as well. Watch my videos, write me in the comments, follow me on social media, and see you very, very soon in my next video. Cheerio!